Hello and welcome to a new case solving video. This time again a free case from the community. Thank you, Jean, for this case and for your support during the solving time because it was kind of a struggle in between. But now everything is clear and working. So it's about stocks, so shares, companies, and we have here some data I want to create from selection. And I also want to concat here the stock and the date and have this as an hard-coded value, name this SD, done, and we can now work here. So level 1, for all the stocks, let's find out how many stocks we have here. So true unique stock, so only 5 stocks. And for all those stocks, we want to calculate the development. And therefore, I first want to know the value at the start. So index value in xmatch stock and date in SD. And we get their value. Now I want to have a lambda function based on this. So stock and date. And here stock and date. This will now not calculate, but I simply save it in the name manager. Stock val. Done. So stock value for Apple at the date. But now I want to have the development, so I need not only the stock and not only the date I buy, I also need the date I sell. I need the buy date twice. So I use here let statement to save calculation time. In this case, it's stock val for stock at date B. And it's stock val stock at date S minus by divided by plus 1. And we can then save this as stock def. Let's take a look if this has worked. Stock development for the stock, fix the row, fix the buy date, fix the column, selling date, fix the column. We have here a value. Let's check this aside. We have there a few errors because for those stocks, if you know Google and Nvidia, those stocks weren't at the stock market at that time. So we simply give them the value 0. And now we can use max lookup to look for the maximum in here, returning the stock name. And we get to our result. So now level 2. You bought a stock on a given date and you sell it within 12 months and you sell for the maximum possible value. So I want to know the next maximum value in the next 12 months and then use the maxfs function. A highly underrated function because I know that it's underrated. I used it, for example, in, I don't know, in a round not too long before. So yeah, underrated. A maximum for the value. The stock is given. And the minimum sell date, buy date. The minimum date is the buy date, so date and then larger or equal than the date given, and also minimum date is smaller than. Now I use the date function because of leap years. A year of this plus 1 month is given, and day of this plus 1, because I've used here smaller and not smaller and equal. But you do not have to worry if this is the 31st and we add 1, it will not get to an error because the date function will then automatically jump to the next month. So, and now date stock val for the buying date, because now we have the maximum value in that period. Stock is given here, date is here, and we can then simply selling minus buying divided by buying, and we get to our result. Now track this down. And we are done. So here, level 3, we have $1,000. We buy Apple, then Amazon, then Google, then Microsoft, then Nvidia at the date given. So AAPL, AM, MZN, Google, GOG, Microsoft, Nvidia. And now I use again the stock def function. Stock is given here, fix the row. Date buy is given here, date sell is given here. And we can drag it aside and then use 1000 multiplied with the product of those developments. And we get to our result. So here you see here there's an error indication, but there is no error because if you round this to the 5th decimal, and as far as I know at the stock market you only use, I think, the 4th decimal, because I've bought and sold stocks for that kind of degree of detail. But here you see it's basically the same result, simply in some decimals far away there was an error or something, or a small difference. So now the rules are the same, but as in level 3, but the order of stocks is not given. And that sounds like a permutation problem. And I therefore use here my permutation lambda. And now you buy all 5 stocks, but the order is not given. So data table and data table and permutation combinations, permutation array, number 5, use 5, and then index of unique stock with those rows given, rows given, and we calculate the stock def. Stock is given, the date I buy is given, and the date I sell is given, and I track this now aside 5 times. We have there some errors, and we can simply, because those are then from stocks not listed at the time and unfulfillable prognose or unfulfillable combinations, and then we make there a 1, and if we then make the product of those 5 numbers, we also get a 0, not a 1, a 0, as it should be. And then equals 1000 times the maximum of this column here. Yes, accept. It's the same as in the example, and then we can data table it. Hello, here we go. Column input cell here. Okay, it will take a short amount of time. The later levels will be even more or even longer. Sorry. Yeah. Okay. Level four, and again here we have a rounding error, as I will show you. Yep. You see all things. All right. Now let's delete the data table and copy this sheet. Take a short amount of time. Hopefully not too long. Here we go. Data table for level 5. Level 5, example 5. And for level 5, we simply need to make one adjustment because now the you don't have to own every stock. So we simply allow same number combinations in our permutation lambda, so that I can also have 111 as a possible combination, and then only own Apple. And then we simply need to track down our formulas and adjust here also our maximum value here. Okay, calculate please. And we get to the same result as you can see here, and therefore we can data table it. Okay. Data table. And use this as your column input cell. This will take a little bit longer, but we will get to our result. At least that is what I'm hoping for. Yeah, here we go. So level 5. Again, where was it? One small rounding error. Okay, delete the data table. And now level 6 will get tricky because we now are allowed to trade 5 times. If you sell something, you have to buy something new. So from there on, you need to stay fully invested. You have 10 dates to choose from, and you can own every stock. So basically, you can also own only one stock for the whole time. So again, data table setup for level 6. And now we need all permutations for the dates. Permutations where we choose from up to number 9, because the last date is as a selling date always given. And we choose 5 numbers, allow some number combinations and something we do not need. But we now have something weird here at the bottom. We start from a later date, and therefore I sort this by column. This will take shortly. And then use the unique function to determine all unique dates with increasing numbers, so to say. Hard copy to save calculation time. And yeah, the remaining stuff we can delete. I want to track this down a bit, at least one row, and then index of our date array given for those states. And now the selling date, so to say, is always given as the last date in our array. And now we want to have our stocks. So unique stocks, unique stock. We know that those are 5 stocks. And we want to have all permutations, 5, 5, allow same number combinations. And we have to transpose this. And you see here we have 3,125 combinations of stocks for 125 date combinations. So for every game we have 390,000 different combinations we calculate. And in my initial attempt, I made a few errors and I calculated, I think it was 12 million combinations with single concatenation for 73,000 rows. So for every game, it was 12 million times 73,000. So a lot of brilliant concatenations. So here, index stocks. Why does this not work? Anyways, make it. And then hard copy. And now I map sequence 5 lambda a stock def index of those stocks here. Fix the row A, index of this here, A, index of this here. I want to have the columns fixed A. Here also, now I was only fix the columns. And then we get there. Okay, something weird. Okay, there's something wrong here. Index A, dates by A. Here, +1, of course, because I sell a date later. Still something weird. A +1. I'm so. Here we go. And then we want to have the product of this, but first we could have there some errors. And then make the product. Now, let's copy this. It's also copied here. Calculate for short instance, and as you saw here, we also get an error message because it's as calculated 39,000 different cases we calculate here for every game. So a lot. And I did some permutation stuff, but never in a two-dimensional space, so to say. So here, somehow Jean likes this kind of permutation stuff. Yeah, I think the graph here is getting fast enough for me to not stop the live stream here or the video here, so I can talk a little bit along the way. Yeah, and in the initial attempt, I had some problems with the dates, and then also with my formula and so on. So yeah, it was a little bit of an hiccup there. So now you see the calculation advancing. Hopefully we will be there soon. Okay. And then the value here is equals 10,000 times maximum of all those combinations. And we get to the same result. And we can now data table this. Data table. This will take longer, so it could be that I make there a short break. Yeah, I think so. So I will be back when the data table is calculated. It finally has calculated. And let's input it in here. And yeah, everything is right, even without rounding. Great. Let's go to the bonus question. If you invest 10,000 and get 10,000 after 10 years, so equals the 10th um, square root. I don't know. No, it's not the square root, but yeah, you know what I mean. Yes, should be right. 25% per annum. You invest 1,000 and get 10,000 after 10 years. What is the um, logarithmic continuous interest? Yes, and if you invest 1,000 and receive 1,000, 100% interest, but the interest is calculated by the second. How much money do you have after 10 years? So it's 1,000 times exp of 10. And here with the rules of level 2, what is the best performance in the data set? So level 2 rules, we simply copy this next to the data and adjust it quite a bit. Criteria for the stock, date is given here, B2, 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 and also stock is given here, date is given here. And then we need to calculate, what was the question? Best performance. Okay. So it's max minus pi divided by pi. Graphic overloading. This. Here we go. Is it calculated properly? Yeah, it has. And then it's equals max of this. And it's right, yes. 290 points. A hard case, especially the not calculation intense case, so to say, but yeah, it was especially level 6 took so long to calculate, so yeah, not too much options. Also 8 dates would have been enough, but anyways, there might be a more efficient method. Thank you for